Hey, welcome back to Restomod 101. Today we're going back to JGM for part 2 of our 351 Cleveland build. What are we doing in part 2? We're doing what's called the blueprint and long block assembly. What does that mean? That means we're working on everything on the top half of the motor. The cylinder heads, the intake manifold, the valve train, cylinder covers, all that stuff. So let's head over and have Ryan show us what's next.
Okay, now with the engine completely short blocked, we can go ahead and install our timing chain and gear set. This particular one here is adjustable, so once we run the numbers and we're not quite happy with it, if that's the case, we do have the option of fine-tuning the camshaft timing with the adjustable timing set. Okay, now that we got our timing chain and gear set installed, I put a crank hub on here which allows us to adapt the timing degree wheel onto the crankshaft. And then what we're going to do is find out exactly where the crankshaft is in relationship to the camshaft, or vice versa. So fine-tuning where exactly those two come into play with each other can really dictate whether or not an engine runs good, great, or awesome. Now in any engine, there's top dead center and true top dead center. And what that means is even though a piston may appear to be at top dead center, there's actually a few degrees of crankshaft rotation where the crankshaft will still be rotating, but the piston will be stationary at top dead center. So we actually need to find out the exact middle of those few degrees of rotation so we know absolutely true top dead center, because all your measurements are based off of that. So once I have top dead center, the relationship between top dead center of the piston and the wheel together as one, then I can go ahead and start running the numbers and find out where the two are together. Start out at 0, go down 50 thousandths on one side, look at your number, the number's 12, and go all the way through the cycle and bring it to 50 thousandths on the other side. Ready to go. And in the rare sense, this is 12 on this side too, which means the first time we put it on there, we actually had true top dead center, which doesn't happen very often. But let's say the numbers were 11 on one side and 13 on the other, then we would have to adjust it over to the 12, and then therefore once you put on 12 on one side, it automatically means it would be 12 on the other. So here we don't have to do anything because it is absolutely at perfect top dead center. So now we can go ahead and find out where our camshaft is. This is a dial indicator that just measures the cam lift. And I want to place that at 0. Bring it around one time to make sure it falls back at the same spot, which it does. And now we can go ahead and start recording our numbers here. Okay, so with the valve open at 50 thousandths lift, which most camshaft manufacturers tend to agree as far as the starting out point to compare camshafts, this particular camshaft is opening just about 9 degrees before top dead center at 50 thousandths lift, which means before the piston actually gets to top dead center, the intake valve has already opened. So we're gonna go ahead and write 9 degrees before top center here. Now we're gonna find out exactly what the maximum lift is of the camshaft. We're already at 50 thousandths, so we're gonna go 100, 200. Looks like it's about 323 thousandths. Now to find out actual lift at the valve, you're going to want to multiply whatever number you come up with there by the rocker arm ratio, then it'll give you your full lift at the valve. So we're at 300, now we're going to go backwards here and find out where the valve closes 50 thousandths prior to it seating against the head basically. So we're at 300, now we're 200 away, now we're 100 away, now we're just going to go to 50, right there. And we're at 10, 20, 30, 40, 4 degrees after bottom dead center. Now what we're going to want to do is find out the exact center of those 2 points. Once we do that, that will establish our intake valve center line, which is where in relationship the intake valve is at wide open to the position of the crankshaft. Determining or fine-tuning that particular position will greatly affect how your engine runs. In this very rare case, after doing or running the numbers here on the camshaft, it's actually exactly where it should be in relationship to where the cam card recommends that it be. They recommend that the intake be on a 107 intake center line, which unbelievably enough, right after the first try, that's exactly where it should be. 7 times out of 10, usually you're gonna have to go ahead and adjust it or fine tune the cam timing to exactly what you need it to be. Switch this dial indicator over to the exhaust side, run the numbers on it.
Does it always go intake, exhaust, intake, exhaust?
No, not at all actually. On the very popular small block Chevy, you'll see exhaust, intake, intake, exhaust, exhaust, intake, intake, exhaust. However, on most all Fords, it goes one after the other. The exhaust opens at 50 thousandths lift, 10, 20, 30, 40, 50, 8 degrees before top dead center. 50, 100, 200, 300. Exhaust valve opens 340 thousandths. Toward that number here. Have to find out exactly where it closes and then figure out the math. So 300, 200, 100, and 50 thousandths. So it looks like we're at about 3 degrees after top dead center. Okay, we have an exhaust lobe center of 117 and a duration of 233, which is within a degree of what the cam card says, so it's pretty much dead on. Cylinder head hardware from ARP. These are head studs, which are traditionally stronger than head bolts. All right, 10 studs in, 10 more to go, and we can go ahead and put the cylinder heads on. Just before putting on our cylinder head gasket, we want to put a little silicone around this water port just for preventative measures. Now that we got our studs installed, we can go ahead and wipe down our deck surface on the cylinder head with a little bit of lacquer thinner. We got the gasket installed already, so we're pretty much ready to go ahead and set the cylinder head on and torque it down.
Just like Ryan put some gasket sealer between the block and the cylinder gasket, put some on top between the gasket and the cylinder head.
With the cylinder head on, we want to be sure to install a little bit of ARP assembly lubricant to the threads. That basically allows enough lubrication to make sure the stud stretches enough to obtain the proper clamping load for the cylinder head gasket. And after these are on, we'll torque the studs down in 3 equal steps, starting with 30 pounds, then we'll go to about 75, and then the final 110. That way, instead of the cylinder head kind of going down like this, everything squishes down and sandwiches real nice and evenly. ARP does provide you with a torque spec, which is right here in this little piece of paper here, which makes it very handy so you know exactly what to torque it to. Norman, I invite you to come on this side of the camera and torque one for yourself.
I can do this.
Yeah, but first step is hike up your skirt, and then see you. Yeah. A little slower, a little more refined.
Not the first time I've heard that.
Good. Now this is going to start to get interesting.
Are you sure all of them were done? I think I skipped a couple.
I don't think you did. Torque it again. Nope.
I got to keep one in here. But I'm left-handed. Did they make this in a left-handed form? So I did that, so now what?
You didn't struggle as much as I was hoping.
Son, did you get tickets today?
To the gun show? Yeah! Okay, we got one cylinder head on. Now we're gonna go ahead and do the other side. After that, we can go ahead and put our valve train on, intake manifold, oil pan and front cover, and then this baby's gonna be ready to go back on the dyno. I'm rubbing this on the face of the lifter because it is the only surface that comes in contact with the camshaft. It is the relationship between this lifter and the lobe of the camshaft that you want to be concerned about when braking in the engine. Now I'm just putting a little 30 weight oil here on the body of the lifter before I slide it on into its bore. This is a flat tappet camshaft engine, being that the tappet has a flat face on it. The other style of lifter is, it looks basically like this, however it has an axle that runs through it with a wheel on it. So at all times it's always seeing a fresh new surface, being, you know, that the flat tappet only has one surface and one surface only to ride on the camshaft. Advantages of running a roller camshaft are, one, reduced friction and the ability to ramp the valve open at or near full lift for a longer period of time, and then close the valve at a very fast rate, therefore allowing more air and fuel into the engine, making more power. The reason you see the lifters at different heights is because as the camshaft lies still in there, you have some lobes that are open, some that are closed, some that are half open. So that's really the reason why you don't see all the lifters at a uniform height. Now we're ready to put the valve train on, basically, which is going to start off with putting the push rods in. There are 8 push rods per side, 16 in total. Again, we'll put just a dab of moly on top of the push rods just for extra break-in protection, and a little bit of moly on top of the tips of the valves. And I have already applied moly inside the rocker arm fulcrum to add protection to that too as well. Just like you would find underneath your kid's teeter-totter. In fact, that is exactly how the rocker arm works. It acts as a teeter-totter with a fulcrum point right in the middle, and it basically, as the push rod pushes up, it teeters down, pushes down on the valve, allowing either fresh air and fuel into the chamber or spent exhaust out. We'll go ahead and start by putting on our rocker arms loosely. Now this is a non-adjustable valve train, so you basically need to make sure that your push rod length and your valve stem tip height is correct. Otherwise, the preload on the lifter will be incorrect. For each valve that you're adjusting, you want to make sure that the cam is on its base circle and has no lift involved in it whatsoever. So you rotate the engine around until you're ready to adjust the particular valve. And then on a non-adjustable valve train, you want to find out how much preload is in the lifter by turns or revolutions of the rocker arm bolt here. Usually you want somewhere between 1/2 and 1.5 turns. Here we're getting an ideal 3/4 turns. And then finally, once you get the lash taken out, torque it to the proper torque spec, and that's all that's involved in adjusting a valve. Let's move on to the next one. Here we are on the other side of the engine putting in our push rods. Well, it's a great day here at JGM. Okay, sorry about the noise here, but currently we have an engine on the dyno, and now that we got all the valve train on and adjusted, we'll be able to go ahead and put on our Edelbrock intake here. In my opinion, Edelbrock makes some of the best intake manifolds in the industry. We're excited to use this piece for our Cleveland buildup. First thing we want to do is make sure all surfaces are clean and free of any kind of debris or grease, oil, anything like that. Spray the back of the gaskets here with 3M spray adhesive just to help the gasket stick to the heads. That way, while we're putting the intake manifold on, the gasket doesn't slide all over the place and get out of position. Gaskets are directional. There is an up side to it. The only little slight modification you have to do is just cut around the gasket right here just so this locating pin will slip over it. Now that we got the gasket good and secure, we can go ahead and put our beads of silicone on the end. A lot of people in the industry refer to as the China wall, which is this little strip of cast iron here on both the front and rear of the engine.
Why do they call it the China wall?
Well, because, Norman, it somewhat resembles the shape of the wall in China, the big one.
Not the little one?
Doing the same exact thing that I did to the block, I'm doing to the intake manifold here, which I'm creating somewhat of a silicone sandwich. So I'm creating 2 thin layers of silicone, and then in between that, I will fill it with another layer of silicone. Kind of have to be both engine builder and cake decorator when doing this.
Is that directional?
Most of them are. You can actually place a Cleveland intake manifold backwards. This is also known as a dry manifold, where there is no water flowing through the intake manifold. Generally, the manufacturer's name and model number go up front towards the engine. Okay, so we've decided to use ARP hardware again for the intake manifold. Not only do they look beautiful, but they're stainless, longer lasting, and just all around a really good fastener. Please keep in mind that there are different length bolts and different diameter bolts too as well, so it's just very critical that you get them into the right positions to begin with. This is a thread sealer. These bolts go into the lifter valley area, which will be, slightly pressurized with oil. So we just put a little sealer on these to prevent oil from working its way up through the threads and out the bowl hole. We're just going to snug the intake manifold bolts up, and then we'll torque them to the proper spec, working our way from the inside out.
What's the torque spec on?
About 25 pounds. Okay, gentlemen, that finishes up today's engine build.
Restomod 101.